Well, I'm Graham Wallis. I'm going to chair this panel. We have something like 70 minutes to go over 70 years of history from the Manhattan Project to today, and we're going to have to move right along.
Okay, we're going to start the introduction soon.
Okay.
Okay.
Okay, so let me introduce the panelists. Win Rockwell will speak first. He was involved with President Carter's commission on the accident at 3 Mile Island. His family has a very long history of involvement with Dartmouth College. The second speaker will be Matt Wald from the New York Times. He will be on the phone. He will be able to hear what we say here, and we can hear him. I hope it'll work out. And the final speaker is Peter Bradford, who is standing up here. He was a commissioner with the Nuclear Regulatory Commission at the time of 3 Mile Island, and he's now involved with the Vermont Law School. So, Win, are you ready to go? I hope the slides are ready. Everybody has more slides than I asked them to have, so we'll try to get going. And if we've already starting late, so maybe there won't be any break. Are you ready, Win, to go ahead? You want to stand up here? Okay, so I can't control you then, can I?
Yeah.
Okay, go ahead.
Thank you. We have to switch over here, and there we are. Are these your notes? Yeah. Make sure we're operational here. Yeah, okay. Good morning. I'm Win Rockwell. Graham, thank you very much for your introduction. I'm pleased to be here this morning with Peter Bradford and Matt Wald. Matt, I take it you're in the Times newsroom in Washington?
That's correct, yes.
Welcome, your voice at least. I stand in contrast to Peter, who spent a lifetime of expertise in this industry, and Matt, who's devoted a major part of his career to reporting on the nuclear industry. I'm a bit of a drive-by. I spent 6 months, a very intensive 6 months in Washington. In 1979, I led the legal team that was investigating the role of the managing utility. And then I conducted, after the federal investigation was over, at the request of GPU Nuclear, I investigated 2 allegations of wrongdoing against the company. But that's the extent of my experience. So I'm here more as a reporter than as an analyst. And before I get going, I want to give particular thanks to Ari Koppel. Ari, are you here? Ari did a lot of the research that generated, thank you, Ari, for, a number of the images and materials I used in this presentation. So, Ari, thank you. At the beginning of 1979, there were 72 operating reactors in the United States and 92 under construction. 52,000 megawatts of capacity from nuclear, which represented about 17% of total U.S. Capacity, and about 25% of the number of operating reactors in the world. It's helpful to remember that civilian nuclear power came into its own roughly in the mid to late 50s. So civilian nuclear power was about 25 years old as of the 3 Mile Island accident, in contrast to the 35 years that we've seen since the accident up to today. What follows is a briefing by NRC engineers 2 days after the accident. And because we're at an engineering school, the confusion, the contradictory statements, and their dealing with the incomplete information they had is interesting today. Whoa. It's not there. Okay, sorry about that. In any event, 2 weeks after the accident, President Carter appointed his commission to investigate the accident, and as you've heard, John Kemeny was named to chair the commission. Here is a set of notes in John Kemeny's handwriting that is his noodling on who might be drafted to be members of the commission. And obviously, from reading the notes, and you can't read them from there, it's obvious that a number of his ideas were directly used in terms of who would be drafted to become members of the commission. And here they are. Ultimately, the commission was 12, a governor, a technology business leader, a journalism professor, an academic health expert, a sociologist, a union leader, a Washington insider, an environmental expert, a nuclear engineer, a theoretical physicist and mechanical engineer, and last but not least, a resident of Middletown, Pennsylvania. 6 of the 12 members of the commission were from the academic world, 9 men, 3 women. The president's charge to the commission was to conduct a comprehensive study and investigation of the accident, and Phil Hanlon described in a number of respects the scope of the charge to the commission and its findings. We're back in Hanover. Immediately after his appointment, John Kemeny wrote out in longhand his acceptance letter to the president, and he writes, "This is an awesome responsibility. I have tried to think of every reason why I should not accept." I worked for John as an assistant to the president for a year after I graduated, and that kind of turn of phrase was very typical of John, thinking about all the reasons he shouldn't do something and then, of course, finding that he should. But when the President of the United States asks one to perform a major service for the nation, the only possible answer is yes. And he goes on to say that the public should know that he hopes to spend the rest of his life at Dartmouth College. No personal ambition served, represents no special interest. My total commitment, he said, as chairman, will be to the discovery of truth and the formulation of recommendations in the national interest, and he pledges the best of which he is capable. 5 days later, he writes a personal letter to Walter Cronkite, saying how appreciative he is that Walter announced John's appointment in a kind way. And in the last paragraph, which of course you can't read, John says, "And Jean and I," John Kemeny's wife, and I, "remember fondly the weekend we spent, Walter, with you and your wife Betsy here in Hanover." So they obviously had a personal connection. Here they are, the commission is in the TMI-2 control room. There's John with other members of the commission. There they are in the containment building with the radiation suits on. That's actually John on the right. There he is on the site. And there he is in quite a typical pose during one of the commission hearings. The accident, of course, occurred in late March, and April was devoted to the appointment of the commission and the beginning of organization of the commission and its staff, and that process continued in May. A huge effort because the direction of the investigation was in so many areas simultaneously. And with subpoena power, we were engaged in legal process, subpoenaing documents, deposing witnesses, as has been mentioned. And the period from June, July, and the first half of August was devoted principally to the active portion of the investigation. And then people began to retreat to their offices to read and absorb all of that we had gathered and learned, and to begin to write. And the final report of the commission was delivered on October 30, 1979. The findings of the commission, the overall finding was this: to prevent nuclear accidents as serious as 3 Mile Island, fundamental changes will be necessary in the organization, procedures, and practices, and above all, in the attitudes of the Nuclear Regulatory Commission, and to the extent that the institutions we investigated are typical of the nuclear industry. And it was this last finding that was repeated and emphasized over and over, the change in the attitudes of the Nuclear Regulatory Commission and the industry itself. The findings of the commission, in brief summary, were as follows. The commission found that fundamental problems were people-related problems, not equipment problems. They found 3 principal causes of the accident: deficient training of control room operators, confusing operating procedures, failure to apply lessons learned from earlier safety incidents. The commission found that radiation doses were so low that the overall health effects were minimal. The major health effect of the accident they concluded, was mental stress. The Commission's estimate of the additional radiation-induced cancers among the surrounding population as a result of the TMI accident radiation release was 0.7, less than 1. That is compared to the then projected 350,000 ultimate cancer deaths anyway, for other reasons, among the relevant 3 Mile Island area population of 2 million. Interesting statistics. The Commission found that the handling of the accident reflected highly uneven quality of emergency planning, confusion, lack of communication, and that the NRC's nuclear plant siting criteria were inadequate. As to public information, they found that the utility minimized the seriousness of the accident, the NRC exaggerated the seriousness of the accident, the media were confused, relying on weak sources, the element of fear was significant, and in a concluding finding with respect to public information, the Commission said neither the utility, the NRC, nor the media were prepared to serve the public well. Some of the harshest criticism was reserved for the NRC itself. Overemphasis on licensing, inadequate attention to assuring nuclear safety, serious lack of communication, these are the Commission's words, serious managerial problems, no well thought out integrated system for the assurance of nuclear safety. The Commission recommended total restructuring of the NRC to become an independent agency headed by a single executive. And as to the utility, the Commission found divided responsibility, lack of coordinated training, and TMI-2 plant management deficiencies. Here's John Kemeny in a pose that was very familiar to those who knew him at Dartmouth at the time, in a classroom, lecturing, computer at hand, and an equation on the blackboard. And years later, after he'd returned to the college and finished his tenure as president, and I believe had retired, he did an oral history in which he recalled the reception of the Commission's report among the public. And in the control, you may want to boost the levels on this so that everybody can hear it.
I remember after it was all over, I was on public television twice. Each time I was bracketed by, well, two like the ones I'm about to describe, where I was bracketed by one very violently pro-nuclear, one very violently anti-nuclear person. I always was given a chance to speak first, just to summarize our main findings and recommendations briefly, and then they would turn to the two antagonists, and each one, in each of the two appearances on public television, ended up praising the report, possibly one saying it was excellent, but perhaps went a little too far, the other one said excellent, but perhaps didn't go far enough. And then I could hardly get the word in edgewise for the rest of the hour, because then they disagreed on everything else from then on. But therefore, on at least two major public occasions by very prominent spokesmen for the two sides, the report was highly praised, and that was typically the reaction to it.
As of today, to complete the circle, there are roughly 100 operating reactors in the United States. That's compared to the 72 we saw a moment ago as of 1979. Under construction, 5 as compared to the 92 at the time of the accident. The total U.S. electric power production, 19% as compared to 17% in 1979, and you can see the data there for operating reactors under construction and so forth outside the United States. Following 3 Mile Island, no ground was broken on a new reactor in the United States until 2013. There has been a great deal of debate and discussion and some speculation as to the reasons that have driven those results between 1979 and today, and I know Peter's going to be talking about that. Others are going to be talking about that. Was it a reaction to 3 Mile Island? Is it a reaction to the economics of nuclear power? Interesting question that will be developed, I think, in some detail today. Recent developments, the NRC approved 4 new reactors in 2012, and just a year ago, 2 new reactors started construction in Jenkinsville, South Carolina, and 2 more in Waynesboro, Georgia. And if my information is correct, others will correct me if I'm wrong, I believe that all of those reactors are in under utilities, which are regulated utilities, and the capital cost of those reactors is automatically built into the rate base, as opposed to being a risk capital investment. In bringing the Dartmouth connections here to a close, I wanted to come back to, you've heard Dan's story about arriving at the commission in, I think it was June of 1979, and some of us thought he was just homeless. but he was very persistent and managed to wangle a job and turned out to be a wonderful addition as a paralegal on our legal team. And one of the stories that he and I were reminiscing about related to a Babcock and Wilcox engineer by the name of Bert Dunn. Babcock and Wilcox was the manufacturer of the NSSS, the nuclear steam supply system, and it was a principal object of our investigation during the accident investigation. There had been an incident in the Toledo nuclear power plant in 1978 in which operators had made some errors. I won't go into the technical detail, but they had made some errors that Bert Dunn identified in a memorandum that turned out to be a warning that was not passed along. And he sketched the potential outcome in very serious terms and said it was a problem that needed to be addressed. Well, in the course of our production of documents and gathering information for the investigation, we had requested materials from Babcock and Wilcox and received boxes of materials from their lawyers in Washington. And some of those boxes were picked up in a rental car. And they were mostly unloaded back up to our offices, but as it turned out, one box had been left in the trunk. And we were getting ready to go to Lynchburg, Virginia, where Babcock's and Wilcox is located, and somebody said, we're missing one of the boxes. And one thing led to another, and it was recalled that one of the boxes had been put in the trunk. So we said, Dan, go get the car, if you can, find the box, bring it back. So he goes out, comes back, and says, the car's been returned to the rental agency. Run, we said, run to the car rental agency, find the box. Ran to the car rental agency, it had been re-rented. So then, in those days, you can't imagine this happening now, in those days, they immediately gave us the name and phone number of the people who'd rented the car next. So we called them, and they had found the box and thrown it into a dumpster. My recollection, Dan denies this, my recollection is that we had someone crawling in the dumpster looking for the box, but in any event, we never found it. So we had to order the documents again. They were not originals, they were copies. We ordered the documents again. They arrived just before we left for Lynchburg. And I remember sitting in the back of a van, driving to Lynchburg, Pennsylvania, with the box on the seat, going through the documents, finding this document, and saying to everybody, wait a minute, listen to this. So that's how we found the Bert Dunn memorandum, which was reflected and reported in the overview of the commission's report. And it's a little bit of the backstory about how an investigation like this, done at high speed with everybody operating on not enough sleep, gets done behind the scenes. So anyway, just to make sure that you understood who we saw coming into the commission. You know, he looks pretty good, doesn't he? And he confessed last night that while he's a member of the class of 1978, he took a little bit of extra time to graduate, and he arrived in 1979, but he did graduate. I want you to know that. And in fairness, there I am. A little bit more hair at the time. Yeah. John Kemeny indeed did go back to Dartmouth, as you know, to be president, and then served as a member of the faculty until his retirement. He died in 1992 at the relatively young age of 66. And you may recall from the handwritten copy of the letter I showed you, he said he was going to spend the rest of his life at Dartmouth, and indeed he did. I actually ran into Jenny. You would appreciate this. My family has a plot in the Dartmouth graveyard behind Massachusetts Hall, and I was going to that plot, and I found in a vale in the cemetery John and Jean's graves. So here he is, no more than 200 yards from here. He did spend the rest of his life here. Thank you.
We're going to move on now with Matt Wald. Matt, are you on the phone?
Yes, here I am. It sounds like I missed some good slides up there.
Tom Cannon.
Good morning, and I'm sorry to be addressing you like I was the operating system in the movie Her. I don't know if you've got my slides up, but if you look at the second slide, it's a picture of me, and you can see I'm not actually Scarlett Johansson who narrates that movie. Unfortunately, I have one foot nailed to the floor here in Washington by this Malaysia plane crash. I'm annoyed that my boss wouldn't let me come up to Hanover, but I do have to put in a plug for the New York Times, my employer of the last 37 years. You don't have to read the paper every day. We just ask you that you buy the paper every day. Next slide, please. There are a lot of emotional approaches to nuclear power. As usual, the New Yorker cartoons are the most articulate. If you look, one of these nuclear workers is wearing a pair of bunny slippers, and the caption is, therefore, emotional protection. But I'd like to look at some numbers here. Next slide, please. Now, I'm going to say something that's so basic that a lot of people have forgotten it. Nuclear reactors are part of the electric system. We don't split atoms for fun and profit. We do it for profit. Reactors get built when people think they'll be profitable. These construction projects get abandoned, or operating reactors are retired when there's no more money in it. This chart shows a lot of detail, but there's one key point. If you look at 1979 on this chart, you will see that the electric demand was climbing a very steep mountain. When 3 Mile Island was ordered, electricity consumption was galloping ahead, and people thought that it would continue to gallop ahead. In the 60s and 70s, the slope was really steep, and people couldn't conceive of it leveling out. Now it has leveled out. That's at the top right side of the screen. If you were a muni or a regulated utility, which is all there was in those days, then running short of electricity was a sin, and the thing to do was to order a reactor. So before the accident, when the slope of demand growth was really steep, the industry was going strong and anticipated having about 1,000 reactors by the end of the century. Then the costs went up and the slope leveled out. Those aren't independent. One reason consumers wanted less was the price was so much higher. Next slide, please. Now, this slide is really an eye chart, and it's not really an eye chart, but it looks like one. I don't think you're going to be able to read it, but I'm going to describe it. It's a little research project I did in 1984. It was pretty dismal. I counted utilities in 9 states where electricity prices would rise between 25 and 50% because of cost overruns in nuclear plants under construction. Then I gave some examples. The 2 Seabrook units in New Hampshire were supposed to cost $900 million for both. By 1984, the estimate rose to $5.8 billion. Unit 2, of course, never got done. In New Jersey, Hope Creek was going to cost $800 million for 2 units, but the estimate was then $3.8 billion for 1. On Long Island, Shoreham was going to cost $261 million. Its final cost was a little over $4 billion. Shoreham, by the way, was going to be one of 4 reactors on Long Island. Today there are none. The 3 Mile Island accident helped stiffen political resistance to Shoreham, technically Shoreham 1. Shoreham 2 and the other 2 units at Jamesport were dead regardless of concerns about evacuations that were brought on by 3 Mile Island. But I have to say that Shoreham is about the only reactor I can identify that didn't get built or didn't get operated for very long because of 3 Mile Island. The essential problem with these cost overruns is that people had very little clue about what they were building. When they broke ground on Shoreham, it was 4 times larger than the biggest plant then operating. It was like the Wright brothers going from the Kitty Hawk Flyer to a Boeing 737. You'd kind of expect them to run over budget and maybe crash a few. Next slide, please. This is from a 1986 study by the Energy Department that I found on my desk a few weeks ago. The left scale is dollars per kilowatt of capacity. A kilowatt of capacity will run 10 light bulbs of 100 watts each. Oops, I forgot. Those are illegal now. Forget I said that. It'll run 1 window air conditioner, an old clunky window air conditioner. So the Energy Information Administration, part of the Department of Energy, ranked the reactors by year of order. In each age grouping, and the left column is what it actually cost to build, and the right is what they thought it would cost to build. The last column is actually fantasy because it groups reactors at the very tail end, and all of them were canceled. In fact, all reactors ordered after 1974 were canceled. In all, we canceled about 125 reactors, some of which were described as being more than 50% complete, and on which more than $10 billion had been spent. And in those days, $10 billion was real money. I think we'd have canceled even more of them, except for a quirk in the way utilities were regulated. In many states, maybe most states, a utility could collect from its customers every penny it spent on building, including mortgage payments during the period of construction, but only if the plant went into service. So if you spent $2 billion on a plant that was only supposed to cost $800 million, and the engineers told you were only half done, that you had to spend another $2 billion to finish, a rational person would say this isn't worth it. A utility executive would say, the only way I get my wasted $2 billion back is to chase it with another $2 billion. So all the reactors ordered after 74 ended up being canceled. TMI-2, however, got under the wire. This accident was related to the boom and bust cycle in nuclear power, but I'd argue not the way people think about it. It was related to the boom, not the bust. It's worth remembering that at the time Unit 2 had its meltdown, it was less than a year old. It was the youngest reactor in the United States. One of the issues was the operators didn't really know what they were doing. Next slide, please. Now, for a while, we thought we were going to return to the era of big nuclear construction. At the time, this is the distant days of, say, 2006, we were worried about the price of natural gas and about carbon emissions. For those of you mathematically inclined, the basic unit of natural gas is 1 million BTU. An efficient generator can take 1 million BTU and produce about 170 kilowatt hours. So in 2006, that meant making electricity from natural gas would cost you about 7 cents just for the fuel. Today, 1 million BTU of gas is in the range of $4, so it's less than 2.5 cents for the natural gas. Remember, we do this for fun and profit, right? So are we having fun yet? Next slide, please. So by 2006, we were talking about 26 new reactors. There were new designs. Locations were announced. Next slide, please. There were license applications. In Texas, one company bought a defunct Kmart and set up a junior college to train young people to work there. The company later took a $350 million write-off and shut down the reactor project. I don't know about the young people. They were studying for the general physics exam, the one they call GPhys. I don't know what you do with a GPhys qualification right now. They wrote off some months of their lives, I guess. Next slide, please. Now, one twin reactor project is going fairly strong in Georgia and another in South Carolina, as was mentioned. The TVA is struggling to finish up a reactor it started in the 80s, but that's about it. None of that is really traceable to 3 Mile Island either. It doesn't really relate to Fukushima either. I have yet to meet a utility executive who takes seriously the idea that in the future, somebody's going to do what the crew did at 3 Mile Island, which is to take $1 billion asset and turn it in about an hour and a half into a $1 billion liability. But there are a couple of subtle factors that really are a threat to nuclear power. And as they say in Congress, after this, I'll yield the balance of my time. Actually, they usually say that after they've used up all their time anyway. I'm sorry, I hope now we've got on the screen the variable generation affects grid operations.
It was one off, now we're there.
Okay, this is a Department of Energy slide from a study on wind production. Here's one of the problems facing nuclear now. It's also not related to 3 Mile Island, and which is why I'm deeply skeptical that 3 Mile Island had a meaningful effect on the construction issue. Nuclear reactors are baseload power, meaning that they're intended to run flat out 24/7. They don't like to have to vary their output. Their operating cost is roughly the same whether they're producing at 50% power or 100% power or even 0% power, and they're not designed to be flexible. In these charts, the gray stuff at the bottom is the baseload stuff, the stuff you need 24/7. But because the wind is so highly variable and mostly blows at night, it cuts a ragged pattern into the baseload. There's just not much space for nuclear. The other half of the problem is that about half of the country's population lives in areas with competitive markets. In those places, utilities don't build power plants. Somebody else looks at the data about sales prices in the hour-to-hour market and decides what kind of new plant to build if it wants to build a plant at all. If it does want a plant, it wants something it can order at the last minute, say a year or 2 years out. They probably want it small. That's the definition of natural gas. Build a gas plant, you're placing a bet on the state of the market in a year or year and a half or 2 years after you're building. Nobody prefers nuclear, which requires a 6 or 10 year prediction at best. So as a result, we do everything now in at least half the country on the short term. Even in the days of 3 Mile Island, the theory is, well, if the reactor's a little over budget, it may look expensive when we start it up. It'll look cheap later because the price of fossil fuels will rise. Well, it turns out we no longer make that bet. We now operate on the premise of cheap natural gas forever. We'll eventually figure out if we're correct. And the last slide, please. Now, I threw this in to tell you, you can never predict what happens in the nuclear business. This car is a 1958 concept by the Ford Motor Company. You put a new reactor in the front every 6 months or so, and it drives for thousands of miles. Nuclear power has, in fact, driven some big changes in the business. Reactor operators now spend 1 week in 6 in training. This is a higher proportion than is the case for airline captains or brain surgeons. Maybe the only people whose ratio of training time to working time is higher is astronauts. The industry has gone to a system of peer-to-peer audits conducted by an industry group, the Institute of Nuclear Power Operations. These can be brutal at times, but essentially the industry has adopted Greenpeace's model that an accident, nuclear accident anywhere is a nuclear accident everywhere, and they are determined not to have another accident like that. As a result, the average reactor is now online more than 90% of the time. At the time of the accident, 75% of the year was considered very good. Now, the number of unplanned automatic shutdowns, it used to be 7 or 8 per year per reactor. Now, on average, it's less than 1. And if you have 4 unplanned shutdowns in 12 months, the Nuclear Regulatory Commission will come to pay you a very nasty visit. We're still not into the nucleon car stage, though. Come to think of it, I couldn't pop a new reactor on the front of this one. I can't even tell which end is the front. Anyway, I thank you for your kind attention, and I look forward to the questions and answers.
Thank you, Matt. I'd like to reassure the audience this is a play in 3 acts. And unlike the usual tragedy, the tragedy comes first. And the acts should get brighter and nicer, I hope, as we go through the day. And when we get to the future, you'll be all happy. Peter Bradford, please go ahead and do your thing here. You can take this one.
Thanks. That's sort of a downer for me. We seem to be in the before and after PowerPoints this morning. This one's more or less self-explanatory. I'll just leave it up while I remark on something that Dan Reicher, I didn't realize I was coming to a Dan Reicher roast, but something Dan said earlier that struck me. Dan and I, a decade ago, taught a course at an institution of higher learning about 3 hours south of here, one from which, as it happened, I graduated. And something Dan said earlier struck me as kind of interesting in terms of the ongoing rivalry between Yale and Dartmouth. On the occasions when I've said to someone, I'm a Yale graduate, it never occurred to me to add, and I know how to read. Haley, that's for Dan. It's a little late. He's done fine, but it's an observation you may want to keep in mind. This graph is obviously not a very serious piece of work, but I devised it a few years ago to illustrate something that interests me in terms of appraisals of the 3 Mile Island accident after the fact. Was a tendency for a number of years to look back on the accident and say, well, it was really overstated, and that overreaction by regulators, by the public, by the environmental community, did a lot of harm and contributed to the decline of nuclear energy. And in fact, as you can see from the way this graph is set up, from about the second day of the 5-day accident sequence on, I'd agree with that. In fact, during much of the footage that you saw in the earlier clips, the public was being, in hindsight, unnecessarily alarmed about the dangers from the conditions as they then existed in the reactor. But what that narrative leaves out, in no small part, as I'll explain in a minute, because it wasn't well understood during the first year or two after the accident, what that narrative leaves out is just how dangerous matters were during the first 12 hours or so of the accident, which is when all the damage was done. The core was uncovered, the fuel largely melted, the radioactivity escaped, the radioisotopes escaped, the fuel rods, some got out of the plant altogether, a lot wound up in the containment, and a hydrogen explosion occurred within the containment. It was contained in large part by the containment, but that's the same mechanism that blew apart the 3 reactors at Fukushima, where the containment didn't have the same strength as the one at 3 Mile Island. So the balance between perceived and relative risk over the 5 days isn't what it was often cranked up to be. There was a period of time when everyone was still asleep in their homes, and no one, including the Nuclear Regulatory Commission and even the government officials in Pennsylvania who would have been responsible for an evacuation, had any very clear understanding of just how serious matters were at the plant. Indeed, the plant personnel themselves didn't. And so if one could somehow go back and say, should there have been an evacuation ordered by the state, you'd wind up saying not at the time the state actually did. You saw Governor Thornburg's recommendation as to pregnant women and small children. But during the first few hours, if anyone had understood the real conditions, they would not have wanted the public within 5 to 10 miles of the plant. And in fact, at that point, there was no evacuation taken. One thing that's important to understand, I think, about what went on during that period is that the extent of the damage to the core, the extent of the melting, the extent of the radiation release didn't become clear until 5 years after the accident. It was not possible for humans to get close to the reactor vessel. The estimates during the year that the Kemeny Commission worked and the NRC did its own special inquiry group analysis were that the core had certainly been damaged, but that it had retained its essential configuration, that the destruction in the core was, I don't remember exactly, but say 5 to 10%. In fact, we now know, but didn't learn until it was possible to get robots close enough to send out pictures, that a good part of the core had not retained its configuration, had slumped to the bottom of the pressure vessel, and that the amount of melting was far above what had been estimated during that first year. So again, when one hears reports to the effect that the accident was overrated, when one reads it in the Kemeny Commission, it's important to keep in mind that no one really knew just how serious the accident was until several years after the fact. Why is it important? Why was TMI important enough that we come back to it 35 years later? Well, first of all, the frequently heard statement that no one died at TMI is at least open to dispute. And I put up the a link to the most serious of the studies that questions the conventional wisdom as to the level of exposure and potential for fatalities by a guy named Stephen Wing and his colleagues at the University of North Carolina. But there are some events that occurred during the accident that were a real jolt to the system of nuclear regulation as it then existed. At that time, it was built in many ways around the premise that it was possible to foresee all likely accident sequences and to guard against them, and that any sequence that was deemed not credible, not possible to occur, didn't need to be guarded against. But several things happened during the 3 Mile Island accident that had officially been deemed for regulatory purposes to be impossible. One of them was the destruction of the reactor core. Another was that the fuel rods would overheat to the point that essentially the cladding, the metal on the outside, would interact with the water, take out the oxygen, free up the hydrogen to go form an explosive mix in the containment. That's the explosion that was contained at TMI, but not at Fukushima. And then finally, at the time of the 3 Mile Island accident, there was no requirement for off-site emergency planning as part of the NRC licensing process. So there were no NRC-approved evacuation plans available when it came time to actually ask people to leave their homes. So as you can imagine, from the standpoint of regulators, having to go back and begin to consider as possible things that had theretofore been considered impossible was one kind of jolt to the system. A more important jolt, one that was also driven home by the events of September 11th, 2001, was that you really can't regulate adequately by depending entirely on your ability to foresee things, and that there are times when you have to simply put in place safeguards against things that go wrong above and beyond those that you're able to foresee. And that is an important lesson both from a technical regulatory standpoint, but also in terms of the economics of nuclear energy and why it's so hard to control nuclear costs, because one always has the burden of trying to foresee and build something to guard against events that are essentially unforeseeable, such as the striking of a large tsunami in Japan. And then finally, the quotation on this slide and the note at the end that it's by a legendary New York Times reporter. Of course, Matt has already read you this quotation, so I've blown the cover of the reporter. What I didn't say was that when Matt wrote this, he was quoting me, but I was actually quoting Victor Galinsky, who was smart enough to have said it casually to me in the hallway one day when we were both nuclear regulatory commissioners. So I'm in no position to call the kettle black as far as borrowing that quotation. Matt's already touched on the last point I wanted to make, which is that for many years it's been argued that 3 Mile Island killed nuclear construction in the US. To me, that's a myth that has done substantial harm to nuclear energy. And the logic basically is after the accident, the NRC overreacted and imposed high costs through regulation. Unscrupulous environmental and anti-nuclear groups exploited the accident. The public became scared and the industry moved in other directions. The problem with this mythologized concept of the role of 3 Mile Island in nuclear history is that it leads to some harmful and incorrect conclusions about how to restart nuclear energy, get political support, streamline the licensing process so that the interveners can't raise questions anymore, and of course, build safer reactors. I won't spend time on the details of this, but There may be people at the Tuck School who'd be interested in commercializing this board game. It essentially just reflects the ongoing and somewhat dizzying debate about what really did do in nuclear construction in the U.S. But here's my own answer to that question. At about the same time as the accident at 3 Mile Island, but actually a little before it and entirely unrelated to it, Congress passed a law called the Public Utility Regulatory Policies Act, and it required the electric industry to change its way of acquiring power generation and to buy power from anyone who could supply it at the estimated cost that the utilities themselves could provide it. That led to dramatic changes in the electric utility marketplace, and for the first time, companies that weren't utilities could build power plants. The utility industry fought the law. They said there'd be blackouts, brownouts. You couldn't trust the new entrants in the market. But in fact, they did very well. And today we have a dramatically different electric power generation industry than we had before 3 Mile Island. And as part of that different industry, you have to be able to compete in those parts of the U.S. that have opened up their power markets to new entrants. As Matt and Wynn both indicated, there are new nuclear plants being built in Georgia and South Carolina, but that's because those states have never really opened their power markets and have stuck with the old regulated model. Under the new model, the risk of cost overruns, the risk of poor operation is shifted to investors, but investors won't bear that risk. They won't put money up for new nuclear construction. And that, and not the accident at 3 Mile Island, is why there have been no new nuclear plants built in the U.S. in the last 30 years, other than the 4 that are now under construction. And if you want to test that hypothesis, look at the countries with competitive power markets in which 3 Mile Island didn't happen. And you'll find exactly the same thing, that no new nuclear unit has ever bid successfully in a competitive power procurement anywhere in the world, including in the countries that did not have 3 Mile Island, did not have overreactions to the accident. And then finally, this reshaping of the electric industry is continuing even now, and you don't have to look any further than what's happened at Vermont Yankee to see a recent dramatic manifestation of that, because there you had the public, a segment of the public, demonstrating against a reactor for decades and getting, as it turns out, nowhere, even when the state of Vermont joined in the controversy on their side. The courts threw out their arguments, threw out the state's position that the plant should shut down. And who shut the plant down? The owners, because in the power procurement market as it now exists in New England, they were losing money, even on an operating reactor. Starting 12 years ago, the national policy direction was headed toward what was then believed to be a nuclear renaissance, what's turned out to be an unfortunate term. And in many respects, those who were pushing the nuclear renaissance built it on the idea that they could put 3 Mile Island behind them by providing strong political leadership and a new licensing process. What they didn't realize they needed behind this idea of a nuclear renaissance was additional, literally hundreds of billions of dollars, because that's what it would have taken to build a dozen or more new nuclear plants. They didn't get enough states to sign on to the kinds of laws that exist in Georgia and South Carolina, and the federal government only put up enough loan guarantee money for basically 2 of the 4 reactors that are being built. And so, as Matt indicated, the so-called renaissance has collapsed from, I count 31, he counted 26 reactor applications at the NRC a mere 5 years ago now, down to the 4 that are actually being built. The bottom line is that 3 Mile Island teaches us a lot of useful lessons about the weakness of safety regulatory systems that are built on the ability to foresee all the dangers and erect barriers against them. It teaches some useful lessons about the difficult economics of continuing to assure nuclear safety. But it doesn't tell us anything useful about the real reasons for the nuclear industry's present dilemmas, which are rooted in a world in which many other energy resources are getting cheaper and new nuclear plants are remaining expensive and inflexible. They take a long time to build. And by risky, I mean economically risky, that is beyond the willingness of private capital to finance.
I'd like to thank our three panelists for their presentations. Very informative, very interesting. Of course, we were supposed to talk about the past, and we didn't say anything about Chernobyl and Fukushima, which may have had more effect than 3 Mile Island. We didn't talk in terms of economics about existing reactors. All the existing reactors, almost all the existing reactors, are being uprated in their power because they had more capacity than they were originally licensed for. And they're renewing their licenses for another 10, 15, 20 years, whatever they can get. And they may try to renew them again. So the existing reactors are paid for, and in the view of some utilities, but not all, they are what they call cash cows. They're there, they've been paid for, and you have to run them and you have to buy the fuel, but you don't have to build the new one, and you can operate the power. So let's move on to the first question, which we had. They had a first question already, and Wynn's going to answer it.
No, Peter is.
Oh, Peter's going to answer it, okay. Alex is going to help me to repeat the question. Can you remember the question, Alex? Would you go up to come over this side?
I think Jenny's.
Do you remember the question? Would you repeat the question then?
It sounds like Jenny would like to repeat the question.
Yes.
Go ahead.
Yes, go ahead.
Okay, so if I could have just a moment. This the question is based on a series of conversations with my father regarding what he personally thought was the most critical issue identified through the commission, which were the attitudes. And as it happens, my professional expertise is dealing with organizations and how they respond to complex issues. For example, British Petroleum in the 90s trying to prevent further plant accidents, and we know how successful that was. There are three attitudes, for example, that we've mentioned today that the commission identified. How critical information that could have prevented the accident wasn't transmitted. How after action reviews, response to an error in an organization, and the ability of an organization, in fact, its eagerness to look to the future, even an undesirable future. The commission recommended restructuring, and I could not agree more strongly with how important those attitudes were. My father had great confidence that restructuring could, in fact, change these attitudes. But the evidence is overwhelming in other organizations that those are deeply ingrained phenomena that don't respond to restructuring, even though it's the most common action. So finally, the question. What can you observe in whatever changes happened with the NRC in terms of those fundamental attitudes? Were there significant shifts? Thank you.
So the question is what fundamental shifts the NRC has addressed?
No, there are attempts, but were there actual changes? Is it
Were there actual
evident
changes?
that
Okay.
those things really did get that?
Peter, would you answer that one?
Peter, go ahead, take a crack at it, but I'd like to add something when you're done.
Sure. And your question begins with the effort of essentially what was referred to earlier as the Dunn Memorandum.
Among others.
Yeah. It's perhaps worth mentioning it that the same event that gave rise to the Dunn Memorandum, the problems with the Davis-Besse plant in Ohio, also stimulated an NRC inspector to keep pushing away, trying to raise exactly the same issues that were in the Dunn Memorandum, and that were in fact clearly precursors to the accident at 3 Mile Island. Not only that, but an engineer in the TVA system had begun to raise the same issues, and they'd been raised by events at the Rancho Seco plant in California. So you're absolutely right that there was a level of complacency within the system, both in the industry, at Babcock and Wilcox, where Mr. Dunn was, and within the NRC, that kept pushing that information back down. It was, everything's safe enough already. It's going to cost time and money to deal with redesigning the pressurizer in this type of reactor so that it doesn't have the same potential to mislead the operators. There's a lot to be learned in terms of looking at why these concerns didn't move forward. Another commissioner I actually met with the NRC inspector. He pushed his concerns all the way up past several layers of management to the commission. And we had just begun to follow up on it. As it happened, our meeting with him was March 22nd, 1978. And so 6 days later, the accident happened. And in a number of ways, the NRC at least did try to dramatically change its capability of learning from operating events. The agency set up a whole new Office of Operational Data Analysis, or some such term, whose purpose was to look at early events, treat them as precursors, ask what else could go wrong, and try to do a much better job of making sure that those kinds of concerns were dealt with. And there were a number of other respects. Creswell himself was given various awards and given a prominent position in investigating the accident, although he became disillusioned and left the agency within, I think, 2 or 3 years after that. So it definitely had a substantial impact. Within the industry, of course, the nuclear licensees banded together and formed the Institute for Nuclear Power Operations, whose broad mandate was to look at what happened, what went wrong in all the nuclear plants across the country, and make sure that the experience was shared rapidly and effectively. So this business of warning events, precursor events, and how they're dealt with was a terribly important theme of the accident. I think you can also say, just looking at what's come out about Fukushima, that for accidents of this magnitude and complexity, the chances are pretty good that there will always turn out to have been precursors. Memoranda from geologists saying that the tsunami standards weren't good enough, and essentially those were treated quite similarly within the Japanese regulatory system to the way the Creswell concerns were treated within the Nuclear Regulatory Commission. So on the one hand, a lot was learned, but on the other hand, it's a lesson we seem to have to go on learning, because after the peak of concern, things fall back and complacency tends to rise up again. Sorry, Matt, that was...
No, yeah, I think all that is true. I would add what INPO is doing, the Institute of Nuclear Power Operations, is mirrored at this point in other industries, and that it often turns out that the government sets a floor for safety and operational standards, but successful industries exceed those. If you look, for example, at aviation, where we used to have 1 or 2 or 3 big crashes a year, now we have a crash every 2 or 3 or 4 years. The reason is that the people in the industry have put their heads together and determined that any mishap at any of them is bad for all of them, and they're going to wring every last bit of intelligence, of smarts, out of every operational incident they have. This is something that is coming to medicine, forced on them by the tort liability system, is present in aviation, exists in utilities to some extent, for example, in grid operations, separate from nuclear power plant operations. And one of the things I think 3 Mile Island taught us in a larger sense is government can do some of these things, but industry in some cases can do it better by themselves.
Thank you very much.
Well, the NRC actually responded to 3 Mile, is still responding to 3 Mile Island. I've been involved with that. I'd like to bring up the point that what criteria does the NRC use to evaluate safety? And there are two they have mentioned. One is prompt fatalities, and one is latent cancers. And so they have a big study now, which you may have seen recently, comes out, shows if there was an accident in two typical reactors, no one would die. And the reason is they could be evacuated effectively. Now, is that the right criterion to use for evaluating safety? I just raised that. Okay. So let's move on to the next one. We could spend all day, really. There's so many issues here, but let's have another question.
Question, what do you see as the interplay of the Navy's role in operating nuclear reactors and in managing that in a parallel structure to the NRC, as well as the fact that it ends up bleeding over operators who go to, your operators in the commercial industry are to some degree former Navy reactor operators and to some degree from the ground up civilian operators.
So let's repeat very quickly.
Okay, so your question is, what is the Navy's role in parallel operation with the NRC? Okay, great.
Well, the NRC actually has to approve the safety aspects of nuclear reactors. I've been on submarines to evaluate that, for instance. They do that. NRC has a safety role with the Navy. Yes, it does. I'm involved with that.
NRC does not have any role with the Navy.
We had to go, well, we can talk about that separately, okay? Let's talk about that separately, because I was involved in doing it. So I would like to respond to that one. Can anyone respond to that one?
I'd like to toss in an idea. The submarines are the only reactors in the world where the operator lives inside the containment vessel.
Yes.
It must have a salutary effect.
And the radiation you get there, they tell us, is less than you get by being up above the ground, because you're protected by the sea from the other kind of radiation you get from here. Yes, the Navy has a very, very good record. Another question. We are over time, so we've got to go very quickly, but I think we could take another 5 minutes or so.
Yes, following Fukushima, there was an effort by several organizations to advocate in front of the Vermont legislature and the Vermont governor about Vermont. And one of the polling results was that there were no lessons to be learned from Chernobyl and from Fukushima. That is, they did not affect public opinion. But are there lessons from Fukushima and from Chernobyl that also are relevant to this?
Yes.
So the question is, are there lessons from Fukushima and Chernobyl?
Well, yes, one of the important ones is that from Fukushima, you can have accidents at multiple reactors. And how do you handle that, especially with these new designs which have sort of modular reactors which you stack in a 12-pack or a 6-pack? How do you regulate that? That's one of the questions.
Multiple reactors, but in conjunction with a natural disaster that significantly affects not only the parameters of the accident, but also the ability of people to evacuate, operators worried about their families, whole dimensions that haven't historically been considered as part of U.S. regulation. And in addition, the Nuclear Regulatory Commission has spent a lot of time on the specific technical implications of Fukushima, because we have that reactor type in 20-some locations in the U.S. So yeah, there's a lot to be learned. Less so from Chernobyl, because it's not a reactor type that we have here, and hopefully not a safety culture that we have here either. But it's not without precursor
The lessons from
qualities.
Chernobyl is that the pollution can go over thousands of miles, can have effects on agriculture in Scandinavia and Scotland, and that sort of restricting your evaluation to 50 miles maybe doesn't make so much sense.
People on Long Island certainly thought they learned a lesson from Chernobyl, which is that they didn't want shore to open.
We have a point here from Avery Lovins. Well, that'll be the last question. I'm sorry we could go on all day, but it's the last question.
Here I hadn't been acquainted with the wing records, so I just looked it up. And in essence, it says quite a few people, as Bob Tredich's book also said, reported symptoms of acute radiation exposure downwind. So this fellow in '97 at UNC did the epidemiology and found a good deal of excess cancer. So I wanted to mention really dug into the raw data, which were very hard to get from the sensors, many of which were somehow lost, unavailable, overloaded, or whatever. But he said he got all the raw data he could and ran them through the fallout codes from Los Alamos, scoping the meteorological uncertainties, which were considerable. And his conclusion was that the source term release was at least 2 orders of magnitude higher than the commission had reported. I asked him if he intended to say or do anything about it. He said no. I asked why not, and he said because the people who misled the commission weren't going to change, so he didn't see any point in it. And I wondered if you, from your NRC and other perspective, you or others had a comment about that. I'm sorry, Ted.
Did you all hear the question? We don't need to repeat it. The point, Bradford.
You know, health physics, especially where low-level radiation dosage is concerned, is a pretty daunting subject and not one on which I have any independent expertise to add. I've been troubled for years with regard to the emphatic conclusion that no one died at 3 Mile Island just because there's no way of knowing. The number of deaths may be undetectable within the broad number of people expected to die of cancer in that area over this period of time. But there are a couple of striking issues raised in the later work, both of Steve Wing and his colleagues, and others who've looked at the radiation releases from potential radiation releases driven by the hydrogen explosion at the plant itself. And one of the difficulties is that most of the radiation measuring devices, and there weren't that many because no one believed there was going to be an accident, but most of the devices in the area went off scale because, as with many of the other instruments during the accident, they were designed, built with the assumption that they would never actually see high or significant levels of radiation. So a lot of assumptions were made that either the top of the scale was the most that happened or that instruments were defective somehow. They don't, I think, provide a very good guide of exposures and potential health effects. But a lot of other people have looked at this over a long period of time and come to different conclusions. What's important to me, though, about the Wing study, and the reason I highlighted it here, is that it is a respectable group of independent epidemiologists. The only one, I think, that was independently funded from the court-administered TMI fund that has looked at the question, and they have reached quite a different conclusion from the official
So we're going to stop here. Thank you very much for all your attention. Thank the panelists. We could go on all day, I'm sure, but we have to move on because we have another speaker coming right behind me. Thank you very much for all your attention this morning.